In this video, what we're going to do is have a look at how an electric shower works. So what we'll try and do is we'll identify the main components. I'll briefly mention the most common faults with these components and just give you a run through of what all the parts do. Before you do any work in a shower, before you take the cover off the shower, you must make sure that the shower is safe. So that means making sure you've got the thing switched off at the pull cord switch, or if you have one of these type of switches, an isolation switch, make sure it's switched off at the isolation switch. That in itself is not good enough. You must check that if you have a circuit breaker, that you've switched the power off at the circuit breaker, or if you've got the old style fuse, you've removed the fuse before you start. Once you're sure that there's no power getting to the shower, it's then safe to remove the cover. So, I think probably the easiest way to go about this is that we'll look through the components from the point of view of the water first, and then we'll go on to the electricity. So when the water comes into the shower and you switch your shower on, the first thing the water meets is the solenoid valve. This is this thing here. It's basically an on-off switch for the water. Whenever it sees power, the coil energises and the water passes through the solenoid. The water then goes on, and the next thing, into the stabiliser valve or the flow control valve. This is this valve here. On some of the really cheap models of showers, they don't have a solenoid, and the flow control valve also works as an on-off valve. So the water then goes into the flow control valve, and in all the flow control valves there's a small pipe or an adapter or something that takes up into the pressure switch. The pressure switch is the part of the shower that recognises that the water is turned on. So as soon as there's water pressure, it will then allow the electricity through to the elements, but we'll come back to that. So for the shower to work, once the water's on, you must have enough pressure to activate the pressure switch. But the other thing that the flow valve does is it alters the temperature. And it's called a flow valve because in fact it doesn't really alter the temperature. What it does do is it alters the flow, the speed of the water through the heating tank. This is this thing here. And what this does is that the quicker the water flows through here, the cooler the shower is, and the more you slow the water down, the more chance it gets to heat up in the heating tank, and the hotter the water gets. And that's really very basically what happens to the water as it travels through the shower. Okay, now to follow how the electricity passes through the shower. The power all comes in at a terminal block here, straight from your pull cord switch or your isolation switch on the wall. It comes in here and goes through the thermal cutout. This is the first thing that the electricity meets. Now, if for any reason the tank is too hot, the thermal cutout won't allow power through to the elements. But we'll assume that we've switched the shower on, the water in the heating tank is cool, and the thermal cutout recognises that the water is cool and allows the electricity to pass through the thermal cutout and on down to the switches. The switches are in here, and this is the top of the pressure switch. And as I mentioned before, if there's enough water pressure, it pushes these up, and the switches then switch the power through to the elements. And the power comes from the switches through to the elements, and the water heats up. And that's basically how an electric shower works. So to help identify the components, and this is a Galaxy shower, but I can show you that it has in fact all exactly the same components as the Triton one we have at the back here. And when you get familiar with the look of these components, you'll be able to recognise that although they're not exactly the same, you should know what they do. So once again, we've got the solenoid that comes into the shower, above it the flow valve, and in this case the pressure switch is not directly connected to the flow valve, it's up here. And so the pressure switch, there's a pipe goes up here, this one here, I don't know if you can see that very well, into the pressure switch, and the pressure switch is here. And as you can see in this one, the two switches are mounted here. So when the water pressure comes on, it lifts the diaphragm in here, and the power is then switched through to the heating tank. And so this is the heating tank. It's different shape, different colour to the previous one. And at the very top we have the thermal cutout. So all of the components are exactly the same in this shower as they are in the other ones. Okay, so just once again to help you see the different parts in the shower. This is a red ring shower, so it's a slightly better quality shower than the previous ones. It has the connector block where the power comes in. Down at the bottom here, the solenoid valve, you can see it's a different colour. And this is the flow control, the flow valve here. The indices moves around like that, You can see that it's pretty similar to the other ones, and tucked in here is the pressure switch with the two switches that allow the power on to go to the elements. The heating tank, you should be able to recognise that by now, and then top the thermal cutout here, it's the black thing with the wires going in to either side. This is slightly more sophisticated in that it's got a time delay on it, so that when you switch the shower off, what happens is it keeps the shower running for probably 5 or 10 seconds afterwards, just to let some cold water run into the heating tank. And these are the kind of things you get when you start to pay a little bit more for a shower. So looking at the faults that normally go along electrically with the shower is firstly the solenoid valve. The solenoid valve, when that starts to go faulty, it usually just cuts the shower off completely. Sometimes it has a sensor in it to make sure that it cuts the water off when your hair's full of soap. That's not really true, but in truth what does go wrong is this often cuts out after about 2 minutes, and after 2 minutes it will shut the shower off. Probably a few minutes after that it will come back on again. So if you find the shower shutting on and off when you're in the shower, the first place to look is the solenoid valve. The next thing is the flow control valve. They seldom go wrong, but you may find that if you turn the shower from fully hot to fully cold, that there's not a huge difference in flow between these two. That can point to a faulty flow valve. Following that, the pressure switch is next. This is a moving part, and because this part moves, it can leak. There's a diaphragm in there, and just the movement of the diaphragm over the years, it can cause it to leak. Following that electrically, there's the thermal cutout. And the thermal cutout means, as I mentioned before, if the temperature in the hot water tank gets too hot, then it cuts out. The problem is if this happens on a regular basis, then the thermal cutout will fail, and you need to replace the thermal cutout. The next thing to look for is one of the elements going in the heating tank. And what normally happens with the elements is you get half power. You've got to turn the shower up to as hot as it will go, but you lose the flow because you're only really working with one element. And very briefly, if the shower has no hot water, the water's absolutely cold, the first thing to look at is the thermal cutout, and if there is some heat, then have a look at the heating tank.